In this question, a scientist has a 0.108 molar hydrochloric acid solution and a sodium hydroxide solution of unknown concentration. The scientist uses the hydrochloric acid as the titrant in the burette and 0.0396 liters of the sodium hydroxide as the analyte in the conical flask. So in our conical flask, we have 0.0396 liters of NaOH. We don't know the molarity of that solution. And we're adding to it a 0.108 molar HCl solution. We're going to need to use this titration graph produced by the scientist to figure out how much HCl needed to be added to neutralize the sodium hydroxide. So looking at our graph, we can see this inflection point here. That is our equivalence point. That is the moment where the moles of HCl added is equal to the moles of NaOH that we have. So looking on our graph here, that's happening at 0.03 liters. So we're actually adding 0.03 liters of 0.108 molar hydrochloric acid. So we can fill that in here. What volume was needed? We needed 0.03 liters. So how many moles of HCl were added? Well, we know the volume, we know the molarity. So let's find our equation for molarity. Here's the solutions page of our reference sheet. The molarity equation is molarity is equal to the number of moles divided by the volume. So molarity is equal to the number of moles divided by the volume. We want to find the number of moles. So let's multiply by volume on both sides. So that'll get cancelled out on the right. We're left with the number of moles is equal to the molarity times the volume. So here, our molarity of our hydrochloric acid solution is 0.108. Our volume that we just found is 0.03. So if we put that into a calculator, we're going to get 0.00324 moles of hydrochloric acid that was added. So we can fill that answer in over here. 0.00324 moles added. We're then using that to figure out how many moles of NaOH were present initially. So looking at our equation here, for every 1 mole of HCl, it has to react with 1 mole of NaOH. So we have a 1-to-1 ratio. So if we had 0.00324 moles of HCl added, that means we must have had the same amount, 0.00324 moles of sodium hydroxide present to start with. Now we know the initial volume of sodium hydroxide. We now know the number of moles, so we can use that in the molarity equation to figure out the concentration. So we already know the molarity equation is the number of moles divided by the volume. So we can go ahead and put in our number of moles we just found, which is 0.00324 moles, divided by our volume given in the question, which was 0.0396 liters. So if we put that into our calculator, we're going to get out 0.0818 molar as our concentration of the sodium hydroxide solution. So we can go ahead and fill that in here. Awesome. So this question works exactly the same as the titration calculations, where you're looking at the images showing the amounts from the burette. The only difference is that here we're using our titration curve to figure out how much of our titrant was added in order to neutralize the initial solution.